Hello friends, welcome to CyberCAD Solutions. In this session, I am going to explain how to handle list of elements in AutoLISP programming. Let us go to Visual Lisp environment first of all. For that, I would like to give you a small shortcut command, that is VLIDE, which means Visual Lisp Integrated Development Environment, VLIDE. Just type that one and press enter. You will get to Visual Lisp environment. Here first of all create a new file, click the first button and just go to window and click tile horizontally. So this is the list file in which we are going to work today. Now I would like to create a small list of elements. So let me write like this. I am declaring a variable my list. So bracket start set q my list of say 2, 5, 7, 6, 8 and close again close the set queue. Now I have created a list with few integer elements. Now we shall see how to read first element from a list, how to read second element, third, fourth or last, or how to reverse, how to process this list of elements in AutoLISP programming. So here we have a list, that is my list with few elements. First of all, we shall try to load this one. So just select this statement by double clicking at the end of this line and pick this second button, load selection. This will load the selected statement or the selected statements into AutoCAD, and here in Visual Lisp console window you can see the loaded list as my list. Now let us check whether my list is created or not. Just select this my list and click load selection. You can see the list is created. Now if you want to read the first element from the my list, how to do that one? So we have a function called CAR which will extract the first element from a given list. So how to read that one? You have to write like this, open parenthesis CAR and my list. So if you load this statement, that will extract the first element from the my list. So select this statement and click load selection. Now you can see 2 is coming in Visual Lisp console window. So that is the first element. Then how to get this second element? So you have to use another function called CADR. So write CADR my list and closing parenthesis. Now select this statement and click load selection. So you can see 5 is returned as the output. If you want to store this returned element into a variable, you have to write a set q and a variable name before to this statement. That is like this. Go to start of the statement, write open parenthesis set q first space and go to end and write a closing parenthesis for the set q. So this will store the first element of my list into a variable called first. Similarly, second element, if you want to store this also, you have to write like this, set q second and closing parenthesis. Now how to extract third, fourth, fifth and any nth number? So for that we have another function called nth. So its syntax is like this, nth index of the element and list. So let us try to write this one. So we have to write like this. Here in index place, that is the position of the element which you want to read. Let us say if you want to read fourth element, you have to give 3 because index starts with 0 and ends with n minus 1. So I am giving 3, which means I want to read the fourth element. So I have to give 4 minus 1 3, and here name of the list, that is my list. Now select this statement and click load selection. You can see 6 is coming, where the 6 is fourth element in the my list. Similarly, if you want to read directly the last element, you can do that one. For that we have a function called last. So write like this, bracket start last from my list variable. So select this statement and click load selection. You can see 4 is returned, which is the last element from the list. Now I am going to create two lists so that I can explain how to combine two lists into a single list. So I am writing like this: set q list1 bracket start list 1 2 close and press enter. Set q list2 list 3 4 close. So select these two statements and click load selection so that you can see two lists are created with names list1 and list2. Now I am going to explain how to combine these two lists. We have a function called append, so we have to use like this: append list1 and list2 closing parenthesis. That's it, the simple syntax. If you have multiple lists, you can add to the end of this statement. So select this statement and click load selection. You can see the combined list is returned in Visual Lisp console window. Similarly, if you want to store this into a variable, write set q, say final list and closing parenthesis at the end. Now load this statement and you can see 1 2 3 4 is returned, which is stored into final list. Now I want to replace one element with another element. Let us say in final list I want to replace 3 with 30. So how to do that? To replace a element within a list, we have to use a function called substitute. So I am going to write it like this: subst is the function name for substitute. Then its syntax is, first of all we have to write new item, that is which is the new item going to replace the old item. So first we need to write new item and the item to be replaced in the list old item, and then in which list this has to happen. So this is the syntax of substitute function: substitute new item, old item, and the list in which this substitution has to happen. So let us try to write this fully. Here new item is 30, the old item to be replaced is 3, and the name of the list is final list. Now select this statement and click load selection. 3 is replaced by 30. If you want to store the returned list into the same variable, that is final list, you can use this same variable with a set q over here like this, so that the replaced new list will be stored into the same list. So select this statement and load. Now the final list is having 30 in place of 3. Now if you want to find how many number of elements are there in a list, we have a function called length. So its syntax is very simple: length and name of the list. So you have to write like this: length and list, say final list. So select this statement and click load selection. You can see 4. You can see 1 2 3 4. There are 4 number of elements, so you can see the same. So this is how we find the length or the number of elements in a list. Okay, now I am going to explain a function called ent cell, which is used to read the name of selected entity. So how to use this? Very simple. Write a open parenthesis in the beginning and a closing parenthesis at the end. Simply select this statement and click load selection. So if you see at the command prompt, it is asking select object. Simply click on any object. It will return two items as a list. So the first item is entity name and the second item is the coordinates list of point selected. That is the point which we use to select the object. Okay, we don't want this point. We want only the name of entity. So how to retrieve this first item from this big list? We have already learned how to read the first element from a list, that is CAR. Okay, so try to write CAR at the beginning of this end cell statement, means CAR as a prefix to this end cell statement, and close CAR parenthesis. Okay, now let us try to load this statement and find what is happening. So make sure that starting parenthesis is closed properly. Now select this statement and click load selection. Now again it is asking to select object as it is asked earlier. So select this line and you can see only entity name is returned. That is how we retrieve entity name of the selected entity. Okay, now try to use this statement and store the name of entity into a variable. So how to do that? Again go to the starting of the statement and write like this: starting parenthesis, set q, ename, and closing parenthesis. Now select this statement, again click load selection. It will ask you to select object. Simply click on this object. Now entity name is returned, which is already stored in ename. So try to find whether it is stored or not. Simply select ename variable and click load selection. You can see it is stored in the ename variable. Okay then. So using all this list handling and end cell function, I would like to write a small program which is to find the length of a line and write it as a text on the line itself. So how to write that program? Okay, let's start. So simply remove this statement and go to the beginning of the program, and I have already told you in the first class that make a habit of writing comments in the beginning of the program. Means what is this program for and how you are going to deal it with. So I am writing a semicolon, which is a must for a comment, which means if you write semicolon at the start of the statement, that means the program will treat it as a comment and it will not execute those statements which are having a semicolon. So you can write any number of semicolons. So I am writing like this: program to read length of a line and show on line as a text. That is what the program will do. Okay, come down by pressing enter. Now we have a standard syntax which we have already seen in the previous session. That is to write a program, open parenthesis, define function, command, colon, the name of the function. I am writing LL, which means in my mind length of a line. Now one open and closing parenthesis and press enter and go to the starting, close the program. So that is what the program standard syntax, but here we need to write the executable statements. So first of all, what do we have to write? We have to make a habit of writing it in a sequence. So first of all, we need to select a line and find its name. So just before we have written the same thing. So I am writing like this: starting parenthesis, set q, e name, that is the name of the line. How can we get this one? By car of end cell function. Means if you write end cell within a bracket, it will return a list which contains the name of the selected entity and the point which is used to select. But to retrieve only name, we are writing car in front of this end cell function. So close car also and again write another close parenthesis to close this setQ statement. This will ask you to select a entity and it will return a list from which we are going to read only name, and we are storing that name in ename variable using setQ statement. Hope all you understood. Now try to load this statement and find whether the name of the line is coming into ename variable or not. So select the statement and click load selection. You can see it is asking select object. I am selecting this line. So you can see the entity name is returned. Find it out whether it is stored in ename or not. So select this ename variable and click load selection, the second button. You can see it is stored. Now how to get the database of this line, means all the properties of this line. So for that we have a function called ent_get. So how does it work? I am going to show the same over here itself. So ent get. This function syntax is ent get and entity name. So this is how we have to use this statement. This ent get statement will return the database properties of selected, not selected, the provided entity name. Means whatever the entity name you provide over here, its database will be returned by this ent get function. So I am going to write e name over here, which means the line entity name will be in this. So this ent-get function will return the line database properties. Let us check here itself. So select this statement and click load selection. You can see many properties like the entity name over here, and it is stored with a prefix -1 and 0, that is the type of the entity. Here 0 is kept as a prefix for this property. Similarly, another type of entity name, and 5 means the handle of the entity, which is unique throughout the AutoCAD drawing, and some other properties are there. So these numbers like 8, 100, 10, 11, all these are called as DXF group codes. DXF stands for DXF stands for data exchange format. So these codes are these 8, 100, 10, 11 and 210. So we will come to this later. So first of all, do remember that 10 is start point of the line and 11 is end point of the line. So for every entity, it will have data in DXF group codes. So this 10 for line is the start point, 11 for line is the end point, and -1 for every entity will store name of that entity, and 0 will store the type of the entity, line, text, circle, like that. So we are going to deal with 10 and 11, where to find the length of that line from start point to end point. Okay then, so I want to store all these database properties list. You can see it's a list of list. So these are sub lists, and all these sub lists are stored into a big list over here. You can see that one. So to store this into a variable, I am writing like this: set q e data and closing parenthesis. So if you select this statement and load this statement, now eData will contain all these properties. So here it is showing in a single line. If you want to show it as a list, we have a facility called watch window. So to open that watch window, simply select this variable, right click and click add watch. You can see a window is opened over here in which that particular variable data is being shown. So if you double click on this, it will open the sub lists in that particular list. You can see -1 storing entity name, 0 entity type, 5 entity handle. Similarly, 8 is layer, 10 is start point, 11 is end point. So all these numbers are called as DXF group codes. Okay then. So if you want to check any entity data stored or any variable data stored, you can simply select that variable, right click and click add watch, so that whatever stored in that variable will be displayed in this watch window. Okay then, so up to here we are selecting a line and we are able to read its database. Then we need to find the we need to read the start point as well as end point of this line from this database. So how to read this 10 DXF code sublist from this big list, from this eData? Similarly, how to read this 11 DXF code data, means endpoint data, into a separate variable? For that, we have another function called associate function, that is ASSOC. This function will read a sublist which contains the given DXF code. Let us try that one. Its syntax is like this: bracket start ASSOC and DXF code, that is 10 I am going to give here, which means the start point of the line, and the database list, that is eData, and close. So this is the syntax: ASSOC, DXF group code, and the data. So if you select this statement and click load selection, you can see only start point data is retrieved. Now let us try to store this in a variable called stp. So write setq stp and closing parenthesis. This will store this start point data into stp variable. But if you observe here, 10, which is dxf code, this is also coming into the start point variable. I just want only x coordinate, y coordinate, and z coordinate. I don't want this dxf group code. So to get a list without starting item, means list without first item, we have a function called cdr. So if you write a cdr over here, means bracket start cdr and closing. So if you write like this and load this one, so if you write CDR in front of this ASSOC function, that will remove the starting item, that is the 10 will be removed and remaining list will be returned as a list itself. That can be stored into this start point. Let us try this one. So select the statement and click load selection. You can see only x coordinate, y coordinate, and z coordinate are returned. Similarly, try to read the endpoint also. So set q end p CDR as usual, ASSOC, this time 11, which is endpoint, eData, close for ASSOC, close for CDR, close for setQ. And if you try to load this one, you can see it is also giving x coordinate, y coordinate, z coordinate, excluding 11 from the list. So this is how we read start point and end point. Now I am going to tell you another function to read the distance between two given points, that is distance function. In this Lisp, almost all the functions are very easy to remember. So to use this one, starting parenthesis, distance, and the variable name with which contains the point coordinates, that is stp end p. Make sure the variables which you have declared must be used as same throughout the program. If you write stp1 here and if you write stp over here, that won't give you anything. So throughout the program, a variable must be given a same name. Variable must be used with the same name. So write distance from start point to end point and close and load this statement. Go to the load selection, you can see it is showing 10, so that is the length of the line. So to store this in a variable, I am writing like this: set q length and closing parenthesis. Now select this statement and click load selection. So length variable is populated with the distance between these 2 points. Now we shall create a text entity using another function called ent make. So this function syntax is like this: ent make and list of properties to create a object. This list of properties must be a list like eData. If you see the eData list, it will show you all the properties required to construct an object. So 0 means the type of entity, and 8 is the layer, 10 is start point, 11 is end point. So what are the properties required to create a text? Here I have written some DXF codes for a text entity. So for every entity, 0 is type of object, we will write text as the type of object, and 10 is the insertion point which we are going to use stp variable. So here stp variable will be used as insertion point, and 40 code is used to represent height of the text. I will give 1, and 50 code is rotation angle. I will give 0, and 1 we have to provide the content in dxf code 1, content of the text. So to provide the content of the text, I will use another small function which I will tell you later. First of all, here we will be using length variable in which we have stored length of the line. So list of properties, let us try to write this list of properties using these DXF codes, text DXF codes, because I want to create a text on the line itself. So we shall try to write like this. So as it is another big list, open parenthesis list, and here we need to write properties like e-data. So to get this kind of small lists, we have to use another function called construct. First of all, let me explain that one, because our list of properties must look like e-data. So it should be like this, open parenthesis and sublists inside that list. So 0 dot line in double quote. So every time writing this dotted list will be a difficult thing. So we can use another function to construct a sublist like this, that is cons function. Let me show you that one. So to use construct function, cons is the function to construct a list. Its syntax is DXF code and data. So this is how the syntax looks for a construct function. So here DXF code is 0 and type is say text and closing parenthesis. If you select this statement and click load selection, you can see very similar list to the line type is coming over here for text also. So this is how we are going to write properties for this list of properties in the end make function. So every time we will use cons function to create this kind of constructive sublists. So the same thing we can cut and paste over here. So that is construct 0 text, that is the type of entity, and then we shall give some insertion point. So what are the different properties compulsory to create a text entity? First is the type, then insertion point in 10 code. So I am going to write it like this, cons 10 stp. This is the variable of start point of the selected line. So I'm going to use the same point as insertion point for the text, and then height in 40 code. So I'm writing like this, construct 40 1 unit, that is the height of the text. So 40 code will store, which is 40 code is for height of the text. Then rotation angle of the text, cons 50 0.0. This is the rotation angle of the text, and in the last content of the text. So content is nothing but length, but here length is a number which will not be accepted by the ent make. So we need to convert this number into a text. As it is a real number, to convert a real number into text, we have another function called R2S. Here R2S automatically converts a real number into text. Its syntax is very simple, R2X and number closing parenthesis, but it has some additional optional arguments are also there, that is number and number system, that is decimal, scientific and other types, and then number of decimal places. So it will be like this, R2S length into decimal system with 3 number of decimals. This is how we write it. So simply select this statement and click load selection. You can see it's been given in double quotes, which means a number is converted into a text. If you want to reduce number of decimals, go over here and change it to 2, which means real to string. Length means the number which is stored in the length variable, and then 2 means into decimal system. Please check the R2OS syntax in online help. Here 2 for decimal system, this 2 for number of decimals. Now select this statement and click load selection. You can see number of decimals are coming as 2. So this is what I am going to use over here as a content. So cons 1 space real to string. So this I am removing. So you can see what we have written over here. Cons 0 text, that is the type of entity. Cons 10 stp, that is the insertion point. Cons 41, that is the height. Cons 50 0, that is the rotation angle. And cons 1 real to string length to 2 decimals. So here we are doing two things. One is we are converting a number into string, and we are also controlling number of decimal places to 2. So that is being given as content of the text. So with this all the compulsory properties are completed. So put a closing parenthesis for list and again another closing parenthesis and for end make. So this is what we need to do in the program, that is the end result. So let us try to load this statement also. So I am selecting this statement and click load selection. Here if you see all the properties on the console window, that means this entity is created in AutoCAD. So let us go to AutoCAD by clicking AutoCAD, activate AutoCAD button over here. So here you can see 10, that is the length of the line. So this is how we write a program to place length of a line on the line itself as a text. So please do remember the DXF codes for a text entity, that is 0 for type and 10 for insertion point, 40 for height, 50 for rotation angle and 1 for content. So I am removing all these items and let us try to understand the program once again. So we are reading the name of entity, means the name of a line using endCell function, and we are retrieving its name only from using char function. From that we are using entget function to read the database of selected line and we are storing in edata variable. And then we are reading the start point of the line using 2-3 functions like associative to retrieve only start point, that is 10DXF code data, and we are extracting only coordinates excluding DXF code. Similarly, we are reading endpoint data using ASSOC function and we are using CDR to exclude DXF code from that point list and storing it endpoint variable, and then we are finding the distance between start point and end point using distance function and storing it in length variable, and finally we are also using cons function to create construction lists in all these sublists, and we are also using endMake function to create a text. Now to check whether there are any errors in this program, go to tools and click check text in the editor. This will check the complete code and it will show you if there are any errors over here in the build output. Okay, there are no errors. So simply click load edit window, load active edit window, which will load the complete program into AutoCAD. Now we need to use LL command in AutoCAD. So go to activate AutoCAD button and click it. Now go to AutoCAD and type LL at the command prompt and press enter. Now it is asking select object. Simply click this line. You can see the length of the line is being shown. Now try to draw another line using some 15 units or 15.55 units and try to use the same LL command on this line. So type LL and press enter. Select this line. You can see it is coming 15.55. So this is how we write a program using different functions to get the length and place a entity, new entity. And I want to give you one more note. In endCell function, here we can also write a prompt. So that is \n pick a line like this. You can write a prompt also which will be shown when endCell is being executed. Again load the complete window into AutoCAD. Go to AutoCAD and type LL. This time it is asking pick a line. If you see earlier it was asking select object, but now it is asking only select a line. So this is how you can control the prompt also while using endCell function. EndCell has an optional argument, that is the prompt. Whatever the prompt you want to show while EndCell is being executed, you have to write it in double quotes over here. \n is new line character which will show the prompt which is following \n in a new line. Means the prompt will be displayed within a new line. So this is how we write a program using all these list handling functions. Practice 2 or 3 times again and again to understand the program clearly. Friends, hope you understood how to handle lists and how to create new objects using AutoLISP programming. If you like this video, please subscribe to my channel and share this video to your friends. Thanks for watching and welcome to the next session. Friends, if you like this video, please subscribe to my channel and share this video to your friends. Thanks for watching and welcome to the next session.